inequalities. Do you guys remember when we dealt with absolute value equations? So let's say I had absolute value of x plus 3 equals 5. Does anyone remember how I solved that? Do what? I've got to account for both my positive value and my negative value. So how many equations did I set up? 2. Do you remember what that first equation looked like? It looks the exact same, just without the absolute value bars, correct? You want to remember what the second equation would have looked like? Look the exact same, except my 5 would be negative, and that's me accounting for the positive value and the negative value. And then I would have solved both equations individually to get x equals 2, and x equals negative 8. Does that somewhat ring a bell from back whenever we solved our equations? Okay. We're going to be doing something similar when we're solving our absolute value inequalities. Okay? Can I go ahead and erase this and move on? So solving absolute value inequalities. To solve the absolute value of ax plus b is less than c, I can also substitute this less than for less than or equal to. It works the same way for both of those. For c is greater than 0. That's a key part right there. Solve the compound inequality. Ax plus b is less than c. If you notice, for that second one in this case, we kept it the exact same, but we just dropped the bars, correct? Very similar to what we did with our equations. The second one, ax plus b is greater than negative c. We still have to account for that negative value, but what do you notice about the inequality symbol? It flipped. So whenever we're accounting for that negative value, we need to go ahead and flip our symbol. Does that make sense? Was I talking about the negative value? Or what was the last thing I said? Do y'all remember? Negative value? Sign flipped. So yeah, whenever we're accounting for that negative value, we need to go ahead and flip our sign. Okay? Any questions about that? Now to solve ax plus b is greater than c, we can also substitute that value for greater than or equal to. It'll work the same way for that one. For c is greater than 0, once again, that's an important part. Why do you think c is greater than 0? Do what? Absolute value. Absolute value cannot be negative, can it? Because it's a distance. So I'm saying that my distance must be greater than 0. So that c value needs to be greater than 0. If it's less than 0, that'd be saying it's negative. Absolute value cannot be negative. So whenever we're dealing with ax plus b is greater than c, solve the compound inequality. Once again, for one of my inequalities, it stayed the exact same. I just dropped the bars. So everyone see that. Same thing down here. I have to account for the negative value. When I account for the negative value, the symbol also flips. Okay? What else do you notice that's different between those two compound inequalities? Do you notice that the word between them is different? One's an and compound inequality. One's an or compound inequality. So, how do you think you're going to remember if it's going to be and or or? Not necessarily. It may not always be that way though. Because we're going to be going from our absolute value inequality to coming up with these two on our own. So we've got to decide if it's and or. I have a little trick for us to use. I would write this on your paper whenever you're doing your assignment. The word goal. If it starts off as greater than or equal to, what letter is that one next to? O, so what do you think it's going to be? Or. So everyone see that? And down here, started off as greater than, and it was or. Correct? So I'd go ahead and write that on your paper so you don't forget. If it starts off as less than or equal to, what is that one next to? A, so it's going to be an and compound inequality. This one started off as less than, and it was an and compound inequality. Does everyone see that? It's just a nice little trick that'll help us get the correct word between our two inequalities every single time. Everyone got that? And like I said earlier, in the inequalities above, you can replace less than with less than or equal to, and greater than with greater than or equal to. It works the same way. Okay? Any questions on that? All right. Can I move on to some examples? So it says, solve each inequality, graph each solution if possible. So for letter A, I have the absolute value of x plus 7 is less than or equal to 2. Absolute value of x plus 7 is less than or equal to 2. Whenever I was solving my absolute value equations, what was the very first thing that I would always do? Not yet. I would make sure what was the case before I started doing anything.
C wasn't negative or less than 0.
I do need to check for that in this case. But what I'm thinking is make sure the absolute value is completely by itself. Do you guys remember that? I don't want anything multiplied by it, added to it, subtracted from it, or divided by it. So is my absolute value completely by itself on A? Yes, it is. There's nothing being multiplied by it, added to it, subtracted from it, divided by it. So I'm good to move on. Is my C value greater than 0? Yes, it is. So I can go ahead and set up my two inequalities and solve them. So for my first one, I always like to write it the exact same without my absolute value bars. So it'll be x plus 7 less than or equal to 2. There's my first inequality. Does everyone see that? It's the exact same without the bars. Can someone help me out with my second inequality?
It's x plus 7 greater than or equal to -2.
Very good. X plus 7 greater than or equal to -2. I'm accounting for that negative value. And when I account for that negative value, I've got to flip my inequality symbol. Okay? What's my starting sign? Inequality symbol. Less than or equal to, right? So is it going to be and or? And. Because my less than is next to A on goal. So I know it's going to be and. Is everyone okay with that little trick that we use? Okay, now I've just got to solve it. I've just got to solve them each individually. So what's my first step on both of them? Subtract 7 from both sides. So what's 2 minus 7? -5. Did this inequality symbol flip or stay the same? Stayed the same. And got x over here. What's -2 minus 7? -9. Did that symbol flip or stay the same? Stayed the same. So here would be my answer. How else could I write my answer? Very good. Negative 9 is less than or equal to x, which is less than or equal to negative 5. Does everyone see that? I would accept either one of those answers, though. So if you don't want to write it that special way, you want to leave it like this bottom one, that's fine. Okay?
Is this all we're doing?
Essentially, yes. Am I done with letter A?
No, you don't.
I got to graph it, because it is possible, because I do have a solution. So open or close dot on negative 9.
Close.
Closed. Open or close dot on negative 5. Closed. And how am I shading on my graph? Am I shading between my 2 points, from the 2 points out? Between. So I want x to be greater than negative 9, but also less than negative 5 at the same exact time. So that'd be this area between negative 9 and negative 5. And there'd be my graph. Any questions on letter A? Does that make sense? Can I erase and move to letter B? Letter B. Absolute value of 8x minus 11 is less than 0. First off, right off the bat, is my absolute value completely by itself? Yes, it is. There's nothing being added to it, subtracted from it, multiplied by it, or divided by it, correct? So it is by itself. What's the next thing I need to check? Huh? What was the second thing we checked for on letter A? Had to do with my C value. I've got to see if my C value is greater than 0, right? Is my C value greater than 0? It's equal to 0, but if you remember on this slide, it says my C value must be greater than 0, right? So is my C value greater than 0 in this case? No, it is not. So I've got to do one of two things. I've got to check to see if it's no solution or if it would be infinitely many solutions. Okay? So it's saying my absolute value is less than 0. Would that be a true statement? No. Because what numbers are less than 0? Negative numbers, and I don't want my absolute value to be negative, do I? So this would be no solution for letter B. Does everyone see that and understand that? Any questions there? Bless you. We good with B? Can I go ahead and move on to the next examples? All right. Solve the inequality, graph the solution. Number 4, is my absolute value by itself? Yes. Is my C value greater than 0? Yes, it is. So can I go ahead and solve this? Yep. Raise your hand if you can give me one of my inequalities.
X plus 3 less than 8, negative 8.
Very good. That's me accounting for the negative value, and I flipped the sign. What's my other one?
X plus 3 is greater than 8.
Plus 3 is greater than 8. Very good. Just kept it the same, dropped the bars. Any questions with those two inequalities? Raise your hand if you can tell me if it's going to be and or. Or. It starts off as greater than, correct? That greater than is next to the O on goal, so I know it's going to be or. And then how would I solve both of these inequalities? subtract 3 on both sides for both of them. Negative 8 minus 3, negative 11. Did the symbol flip or stay the same? Stayed the same. 8 minus 3, symbol flip or stay the same? Stay the same. So here would be my answer. X is less than negative 11 or X is greater than 5. Questions on 4? Got to graph it. Is everyone okay if I go by 2s? Yes.
Okay. Does it have to be in that order?
No. If you add X is greater than 5 or X is less than negative 11, that's fine. Okay? It's a good question. Open or closed dot on negative 11. Open. Open or closed dot on 5. Open. And how am I shading? To the left of negative 11, because I want it less than negative 11. Don't forget your arrows on your shading. And to the right of 5, because I want it greater than 5. Don't forget your arrows on your shading. Questions on number 4? Can I erase and move to 5? Number 5. Is my absolute value by itself? No. What do I need to get rid of? The minus 3, right? How would I get rid of that minus 3? Add 3 to both sides. Negative 6 plus 3? Negative 3. All right. So I have the absolute value of n plus 2 is greater than or equal to negative 3. Negative 3 is less than 0. Very good. My C value is not greater than 0. Correct? So am I able to set up 2 inequalities and solve them? No. Does anyone have any idea what my answer might be? Not no solution. Let's be a little more specific than infinitely many solutions. Because with inequalities, I always have, or most of the time I have infinitely many solutions, right? All real numbers. Okay, let's think about this one for a little bit. It's saying my absolute value is greater than or equal to negative 3. Is that absolute value ever going to be equal to negative 3? It wouldn't be equal to negative 3, but it could be greater than negative 3, right? Remember, it only has to meet one of those conditions for that inequality to be true. Any number that I pick to plug in there is going to give me a positive number, correct? Because of those absolute values. Any positive number will always, always, always be greater than negative 3, correct? So that's why it would be all real numbers. No matter what number you pick, it'll make that inequality true. Does that make sense for number 5? Any questions on it? Can I erase and move on to number 6? I wouldn't be able to, I guess I could graph it, but all real numbers would just be the whole number line, right? So you could draw your whole number line and shade it if you wanted to. But if it's all real numbers, you don't have to do that. And the last one right here is my absolute value by itself. 3 times the absolute value of d plus 1 minus 7 greater than or equal to negative 1. It is not by itself. What do I need to do first to get it by itself? Add 7 to both sides. Negative 1 plus 7, 6. It's my absolute value now by itself. No, it is not. What do I need to do now?
Divide by 3.
Divide both sides by 3. Absolute value of d plus 1 greater than or equal to, what's 6 divided by 3? 2. Is my symbol correct here? Yep, it stayed the same because I did not multiply or divide both sides by a negative. Is my absolute value now by itself? Yes. Now I need to check my C value. Is my C value greater than 0?
Yes.
Yes. So can I go ahead and set up 2 inequalities? Very good. Raise your hand if you can give me my first inequality, or one of my inequalities.
2 plus 1 greater than or equal to 2.
Very good. Just kept it the same. Drop the absolute value bars. Raise your hand if you can give me my other inequality. Yes.
3 plus 1 less than or equal to negative 2.
Very good. D plus 1 less than or equal to negative 2. Counted for that negative value, and I flipped my inequality symbol. Raise your hand if you can tell me if it's going to be and or. Or my original one over here started off as greater than, which is next to the O, so I know it's or. Any questions about that setup? And then how would I solve both of these? Subtract 1 from both sides. So 2 minus 1. 1. Symbol flipper stay the same. Stay the same. Negative 2 minus 1. Negative 3. Symbol flipper stay the same. Stayed the same. Bring down my or. Here's my answer. Once again, if it's not in that order, that's fine. Some of you may have put that other inequality first, which would have put d is less than or equal to negative 3 first. So either way would be fine. Now I need to graph it. Open or close dot on 1. Closed. Open or close dot on negative 3. Closed. And how am I shading? Negative 3 is going to the left because I want it less than negative 3. One is to the right because I want it greater than 1. And there would be my graph. Questions on that last one? We all good with absolute value inequalities? Here's our assignment. Page 95, numbers 2 through 18 evens. This will be due tomorrow, the 13th, on Canvas. It's not too many problems. Should be able to knock it out pretty quickly. Are there any questions before I stop the recording?